Welcome to Tommy's Maths Miscellaneous today. This is a quadratic, and from the information given in the question, I will try to give you some simple, easy, elegant method. I always prefer simple things. I always prefer elegant things. I always prefer that after you work, you feel nothing. But I can't put 100% of the problems in that list, but I'm sure 99% I can put in that list. Now look at the question. Let A, B, C be real. If ax square plus bx plus c equal to 0 has two real roots, alpha and beta, where alpha is less than minus 1 and beta is greater than 1, then show 1 plus c by a plus modulus of b by a is less than 0. Not a big thing given here. Ax square plus bx plus c, it is having real roots. One root is less than minus 1 and another root is greater than 1. This has to be proved. I am just starting it with very simple a refinement, I can say. Let us say alpha is minus 1 minus delta 1 and beta is 1 plus delta 2, where delta 1 and delta 2 are positive. If delta 1 and delta 2 are positive, won't minus 1 minus del 1 be less than minus 1? That's what given. And 1 plus delta 2, if delta 2 is positive, won't it be greater than 1? Let us have it. Is there anything, a big thing I am doing? I will never do big things at all. Okay? Now, sum of the roots. Minus 1 minus del 1 plus 1 plus del 2 is minus b by a. Is minus b by a. So, minus 1 plus 1 will get cancelled. Del 2 minus del 1 is minus b by a. So, modulus of del 2 minus del 1 is modulus of minus b by a, which will be modulus of b by a. Okay? So, I have the first information with you. Modulus of del 2 minus del 1 is modulus of b by a. Many a times I speak the same thing in most of the videos. I always say I do things which you know very well. So this is information 1. What is information 2? What is information 2? Product of the roots. Alpha beta. Minus 1 minus del 1 into 1 plus del 2. Minus 1 minus del 2 minus del 1 minus del 1 del 2. But that is c by a. Product of the root is c by a. Now what do we want? 1 plus c by a plus modulus of b by a. 1 plus c by a plus modulus of b by a. This is equal to 1. What is c by a? Minus 1 minus del 2 minus del 1 minus del 1 del 2. And what is modulus of b by a? Plus modulus of del 2 minus del 1. Now, mod x is x when x is positive. Mod x is minus x when x is negative. If del 2 minus del 1 is positive, then when I remove the mod, it will be del 2 minus del 1. So 1 plus c by a plus modulus of b by a is equal to this and this will get cancelled. Minus del 2 minus del 1 minus del 1 del 2, and this will be plus del 2 minus del 1, provided del 2 minus del 1 is greater than 0. All this is positive. Del 1 and del 2 are positive. So before a positive I have a negative. So what will be 1 plus c by a plus modulus of b by a? It will be negative. It will be negative. So I say 1 plus c by a plus modulus b by a will be less than 0. This is case 1. Case 2. Case 1 I have finished. Case 2. Case 2. 1 plus c by a plus modulus of b by a is equal to this 1 and this 1 will get cancelled, minus del 2 minus del 1 minus del 1 del 2. If del 2 minus del 1 is negative, then it will be minus of that. Minus of this, so it will be minus of that. So here you will find del 2, del 1 and del 1 will get cancelled. Del 1 and del 1 will get cancelled. If del 2 minus del 1 is negative, it will be negative of that. So I have written the negative of that. So here what is it? Minus 2 del 2. Take out outside. So whatever you have inside is positive before you have a negative sign. So in this case also it will be negative. Okay? I will again go through that. Now we will again go through that. Let ABC be real. If ax square plus bx plus c equal to 0 has two real roots, alpha and beta, where alpha is less than minus 1 and beta is greater than 1, then show 1 plus c by a plus modulus of b by a is less than 0. Just fast I'll explain again. You have alpha as minus 1 minus del 1 and you have beta as 1 plus del 2. If del 1 and del 2 are positive, the condition will be satisfied. Then go for the sum of the roots and product of the roots and carry on, you will get the answer. So it's a very interesting question, a very lovely question, a very simple question, and I have not used any big theory. These are elegant, beautiful, excellent methods where after working you will feel it is tremendously easy. So practice this and we'll meet in the next video with more interesting questions.